Yeah, okay, so we'll start in 2 or 3 minutes. We will wait if someone else joins. Yeah, so let's start. So hello everyone, my name is Rajan Mukherjee, and I will be taking this live session for like problem solving session for NPTEL course on computer organization and architecture. I am a research scholar in the Department of Computer Science Engineering, IIT Kharagpur. So like as usual, we'll be solving some questions which are typical for your exams and for assignments this week. So please feel free to ask any question regarding the problems which you are solving in the chat. So let us begin. So this is the first question. Consider the following statement. Uh, Statement 1. In programmed I/O, several instructions are executed for the transfer of each word of data. Statement 2. Programmed I/O is not suitable for high-speed data transfer. Which of the following is correct? A is option 1 is true, B option 2 is true, C both 1 and 2 are true, D both 1 and 2 are false. So, um, so let us begin. Like start with this question. So, so if you have gone through the text of programmed I/O, you will know these statements. Like, um, programmed I/O is not suitable for high speed data transfer. Why? Why? So, reason one is several program instructions have to be executed for each data word transfer between I/O and memory. So it is not a continuous process. Like programmed I/O, like several program instructions have to be executed for each data word transfer between IO and like memory. So there is another reason. So like devices like disk have synchronous mode of operation. So what is the problem? If a like so since the devices have like disk have synchronous mode of operation, what will be the side effect? Side effect is limited bandwidth. So it cannot be, so high speed data cannot be executed, like cannot be used for high speed data transfer cannot be used for programmed IO. So the correct options will be correct is option C. Both 1 and true are 2 are true. Both of them are true. So these questions just gives you a kind of revision for you for like when you have gone through the programmed IO, you know these are the basic concepts that are there for programmed IO. So this was a very easy problem. I guess you don't have any doubt because these are very easy theoretical question. So let's go to the next question. So it is given, so consider a programmed IO system where 20 instructions are required to be executed for transfer of each word of data. The cycles per instruction of the machine is 1.5 and the processor clock frequency is 2 gigahertz. The maximum data transfer rate will be how many millions per word? Assume 1 million is equal to 10 to the power 6. This will be 10 to the power of 6. So it is given the programmed IO system has 20 instructions that are required to be executed for transfer of each word. Like for each word of data, we need to set 20 instructions. And the cycles per instruction, the number of cycles, you know this term, cycle per instruction, we have discussed in previous class, of the machine is 1.5. And the processor clock frequency is 2 gigahertz. So the question is, what is the maximum data transfer rate? So time required for each word transfer So time required for each word transfer, what it will be? What are the number of instructions? 20 instructions for each word. For each word, we need 20 instructions. What is the cycles that are per instruction? 1.5. Right? So now, what is the clock frequency? Is 2 gigahertz. So what is the clock frequency? Clock frequency is basically 1 by time period. So it will be 1 by 2 into 10 to the power of 9. Right? So it will come out to 15 nanoseconds. Like 15 into 10 to the power minus 9 seconds. That will be 15 nanoseconds. Now, what is the maximum data transfer rate that can be achieved? So, for each word, this is the time required. So, what is the maximum data transfer rate? So, max data transfer rate is 1 by 15 into 10 to the power of minus 9. That is if you calculate, it will come down to 10 to the power of 9 divided by 15. If we calculate in terms of millions, it will come down to 1000 into 10 to the power 6. Now this will be 66.67 million words per sec. Right. So this is one. This one was a relatively easier sum. Like the question was given, what is the time required for each word transfer? So like I will. I will repeat it once again for everyone. So it is given a programmed I/O system. A programmed I/O system has, like, it requires 20 instructions for transfer of each data of word. Each data of word, for transferring one data of word, it requires 20 instructions. What is the CPI given? Number of cycles required per instruction is 1.5. Next, it is given like clock frequency is 2 gigahertz. So the time required for each for each word transfer, time required for each word transfer is basically 20 into 1.5. That is 20 is the number of instructions plus into number of cycles per instruction. And what is the cycle? One cycle is the clock frequency is given is 2 gigahertz. So 1 by 2 into 10 to the power 9. That is the one clock cycle. So total time required is 15 nanoseconds. So max data transfer is basically we have to give it in terms of number of words per second. We have found out for time required for each data transfer. So max data transfer rate will be 1 divided by that. So it will come down to 66.67 million words per second. Clear? So let me know if you have doubt regarding this. This is a very typical problem that will be asked. Okay, let's go to the next problem. So which of the following statement is true, is or are true for DMA data transfer, like direct memory access data transfer? Option A, data transfer requires very less CPU intervention. Option B, suitable for transferring large blocks of data. Option C, allow direct data transfer between I/O and memory. So if you have gone through the theory of direct memory access, you know what happens, right? So there is the CPU, there is the I/O device, and there is something we called DMA controller. So what happens in direct access memory? The CPU gives us the responsibility of data transfer operation to this DMA controller, and the DMA controller in turn transfers the data across the I/O channel, and it stores the data in memory, which basically used to be done previously by CPU. That entire management operation is done in this case by DMA controller, and when the operation is complete, it sends a signal to CPU that okay, the data transfer is done, now you take back the responsibility. So if you look at all the options given, so option A is true. It requires very less CPU intervention, like absolute minimum. It requires very less, like only the first and the last step, the initiation and the like end of the operation are signals. Those are the only typical signals that are required CPU intervention. Option B, suitable for transferring large blocks of data. Yes, because the reason is because the CPU don't have to take the responsibility, and it can go and do other works in that case, like when the data transfer takes place between the IO and the memory. So it don't have to get bothered in this operation, in this data transfer operation. Instead, it can focus on other more important operations. So this option is also true. Option C is Option C is allow direct data transfer between IO and memory. Yes, it allows direct data transfer between IO and memory. It doesn't require the intervention of CPU. So that again the problem, it solves the issue that CPU don't have to be. So if you have a slow IO device, CPU don't have to have the responsibility. Okay, I will finish this task, then I will go for the other. So option A, B, and C, all three are correct. So if you have any doubt, you can ask regarding this. So this one is clear. Okay, so let's go to the next problem. So the next problem is, suppose the rotating disk of speed of a rotating disk is 3600 RPM. So a rotating disk is given, and it has a its rotating speed is 36,000 revolutions per minute, with average rotational delay of 10 milliseconds. So each the delay of rotational delay is 10 milliseconds. Suppose there are 512 KB of data recorded in each track. So last week we have discussed like what is a track, what is a sector, what is a what is sector and all. We have discussed. So now it is given that once the disk reach the desired track, what is the sustained data transfer rate? What will be the data transfer rate? Right. So rotational rotational delay is given as 10 milliseconds. So the track has data of 512 KB. So once the disk head reaches the desired track, the sustained data transfer rate will be what it will be. So generally it will be data transfer rate is equals to 512 KB divided by 10 MSc, that is 512 into 2 to the power of 10 sorry 10 to the power of 512 divided by 10 into 10 to the power of minus 3 sec kb. That turns out to 512 into 10 to the power of 3 kb. So this is basically, this 10 to the power 3 is basically an m. 512 mb. So it becomes 512 divided by 10, 51.2 mb per sec. So that is the answer. So let's discuss this once more. So the thing is given is, we have given the rotational speed of the disk, that is 36,000 rpm, average rotational delay. So the delay for the disk to reach at the particular track, that is 10 milliseconds. Suppose there are 512 bytes of KB data recorded in that track. So once the disk reaches the track, the desired will be. So for reaching the track, we need 10 milliseconds, and then the data transfer will happen. So data transfer rate will be 512 KB divided by 10 milliseconds. So that will come down to 5.12 MB per sec. You have any doubt regarding this, you can ask. Okay, so let's go to the next question then. So this one is again based on the DMA mode. So which of the following registers needs to be initialized before transfer of data in DMA mode? Memory address, word count, and address data on the disk, address of data on the disk. So I explained it again in question number 3, I guess. So there is CPU, there is DMA controller, and there is IO, and there is memory. So CPU gives the control for data transfer to DMA controller. DMA controller allows the data transfer between input output device and IO. So if you have gone through the data like this theory, you know, like memory address is initialized by CPU. Why? Because you need to tell the DMA controller to which memory location the data has to be stored, or from what memory location the data has to be transferred to the IO device. So that is the reason to let DMA controller know the location on memory for data transfer. So that's why the memory address register is initialized by CPU. Next is word count. So, other than telling the DMA controller like the what is the address for the memory, it also need to tell him how many data word count, like how many words it needs to be transferred between the IO or the memory respectively. So, this also has to be initialized by CPU to for the DMA controller, so that it can knows number of words to be transferred between IO and memory. The last one is address of data on the disk. So again we need to that memory address and IO basically they have the way CPU addresses them, they have a separate address block for memory and IO. So that address also need to be told, like address of data on disk. Since the CPU also need to tell the DMA controller like what is the address from the input device it has to transfer the data to or from the memory with respect to the memory. So all the three has to be initialized so that the data transfer can takes place between the IO and the memory with the help of a DMA controller. So that is the notion of this question, like which are the address register needs to be initialized. So all of them. All of them need to be initialized. So if you have any doubt regarding this, you can ask. Okay, so we will move to the next question. So the next question is, consider the following statements for bus implementation. First is, bus width defines the number of wires available for the bus in the bus for transferring data. Number 2, bandwidth defines the total number of data that can be transferred over the bus per unit time. And the options are A is only 1 is true, B only 2 is true, option C both 1 and 2 are true, option D both 1 and 2 are false. So bus width is equivalent to the number of wires available. Number 1. Number 2, bus bandwidth indicates total amount of data that can be transferred per unit time. So these are like very basic things. Like bus width basically defines the number of words that are available. So the number of words that are available is gives the bus width. So if there are 6 words, then the bus width is 6. That allows the amount of data that can be transferred. And the bandwidth is basically the amount of data that can be transferred per unit time. This is the very basic definitions of bandwidth. That has been prevalent. So the correct answer is option C. Both 1 and 2 are true. So let's go to the next question. So question is, consider a matrix keyboard consisting of 256 keys organized as 16 rows and 16 columns. How many port lines are required to interface the keyboard? So it is said a matrix keyboard has 16 rows and 16 columns. So it is said how many port lines are required to interface this keyboard. So the answer is very straightforward. Like for each row, there will be one port and for each column there will be one port. So if you ask me why only 2 will be required, so consider it like a array thing. So suppose we have a 16 cross 16 array. So to reference it, how many variables you require. So suppose you have to reference. Suppose this is referenced by I and this is referenced by J. So to reference it, you need to find a particular value in the array. You will require to run 2 loops, one loop for I and one loop for J. The first loop will run from 0 to 15 and the second will also run from 0 to 15, right? So this comes from the basic application of array. So you require, okay, how many addressing here? 16. And how many addressing here? 16. So total addressing you require is 16 plus 16, 32. So the correct answer is option D. Clear? So so if you have any doubt, I will repeat it once again. So it is said that the keyboard is a matrix keyboard of 256 keys and it is organized as 16 rows and 16 columns. So how many port lines will be required to interface the keyboard? So consider it as a like an array or a matrix. So how can you reference a particular position? You require two identifiers, right? One is for the identifying which row, and another is identifying which column. So for identifying which row, there are 16 rows, so you require 16 16 ports or key, something like whichever term you want to use. And for referencing each column, for referencing a particular column, so again there will be from 16 values you need to choose. So it will be, the total will be number of ports you will require is 16 plus 16, 32. So if you have any doubt regarding this, you can ask. So if the number of keys is less than 256, yeah. So see, suppose if it is like if it is addressed as, suppose it is said that it does not have 256 keys, but it has 240 keys. Think about it. How many what will be the size of the matrix? It will be, say, 16 cross 16, right? Because you need to interface it in like that, since it is given it is a matrix. So in that case also it will be addressed as the same. But suppose it is said that instead of 16 cross 16, like you have a one with 192, suppose 15 cross 15, that is 255. So it has 255 keys. So in that case, how it will be 15 plus 15. So basically, how you reference an array, that way you need to think. Okay, for different it is a matrix. If it is not a matrix, then some other way you need to reference it. Like it is similar to hard concept you use for array referencing. Okay, so let's go to the next question. So suppose it is required to transfer 20k data bytes in interrupt driven mode of data transfer. For every time an interrupt occurs, it involves the transfer of 64 bytes of data. That takes 20 microseconds for the processor to service. The time required for 20k bytes of data will be how much milliseconds? So it is given that to we need to transfer 20k byte of data in input interrupt driven in interrupt driven data transfer. So what happens, every time a interrupt occurs, it involves transfer of 64 byte of data, right? And that takes 20 microseconds. So for transfer of 64 bytes of data, one interrupt takes 20 microseconds, right? So now total data transfer, total data you need to transfer is 20k bytes, right? So for transfer of 20k bytes, it will take 20 into 20 divided by 64 64 B into 20 sorry 20 into 10 to the power minus 6 seconds divided by 64B into 20 into 10024 into 20 to 10024 B. So what will be the value here? It will come down to so it gives byte con 2 to the power of 6, it will leave 2 to the power of 6 to the power of 6, so it's got, will get ultimately, this is 2 to the power of 6, 2 to the power of 10, so that is 2 to the power of 12 divided by 2 to the power of 6, 4, to the power of 6, that is 10 10 to the power of minus 4 6400 ms. So that is the answer. So let me repeat it once more. So it is given we need to transfer 20k bytes of data in an interrupt driven mode of transfer. Every time an interrupt occurs, it involves transfer of 64 bytes of data, and that takes 20 seconds. So for this processor therefore to transfer 64 bytes of data, for transferring 64 bytes of data, we need 20 microseconds. So what is the total data you need to transfer? 20k bytes. So that is 20 microseconds divided by 64B into 20k bytes. So that will come down to 6400 ms. You have any doubt, you can ask regarding this. Yeah, it will be, sorry, it will be Yeah, it will be this one is basically 64 into 10 to the power minus 4, that is 6.4 into 10 to the power of minus 3, that is 6.4 ms. Sorry, the unit was wrong. 6.4 ms, that is the correct answer. So let's go to the next question. So it is given, which of the following are advantage of serial bus over parallel bus? Option 1 is low implementation cost, option B is high speed, option C no interference, option D all of the above, all of this. So so in a serial bus and a parallel bus, so what is the difference? In serial bus, like each each has to be like you need to have a channel through which every device on the bus has to be checked whether from there data has to be transferred or not. Whereas in a parallel bus, you can ask any of the device at a time, like whether there has to be parallel data transfer to be done or not. So if we do a difference between serial and parallel bus, so it is serial is low cost. You need only one bus channel to implement it. Parallel is high cost, multiple bus will require. Next, high speed. Parallel is high speed because you can directly transfer data from the device connected to the bus, whereas serial is low speed because each device has to be asked whether data has to be transferred or not. Next, serial bus, yes, it does not require any interference. And that is also no interference in this case. Both cases no interference. So option A true, option C false, no, option B false, option C true, right? So correct answer is option A and C. Again, this is another theoretical question that is like commonly asked in many exams. Okay, so let's go to the last question. So what is the maximum data transfer rate supported by USB 1.2.1 and USB 3.0 standards respectively? In these are questions which are not like you need to remember these values, else it's not possible you can write these answers. So I will quickly write down the values for all USB devices. So USB 1.1 up to 12 Mbps, USB 2.0 up to 480 Mbps, USB 3.0 up to 5 Gbps, USB 3.1 up to 10 Gbps. Right, so these are the values. This was given in the slides, I guess. So the correct answer is option B, 12 Mbps and 5 Gbps respectively. 12 and 5. So that is the last question for today. So if you have any doubt regarding any of the questions that has been discussed here, you can ask, I will repeat. So out of all the questions, I will say like question 2 is one of the important questions. Like these kind of sums will be very much given. Else the DMA questions are very important because those property type questions are very commonly asked. This one is also important. This question 4. So while you need to find out the data transfer rate. Another is this one, like for like interrupt driven mode data transfer, how much time will be required. This is another big important question that will be asked mostly. If you have any doubt regarding any of the question, you can ask me now. Question 5, okay. Yeah, so if you have like gone through the DMA controller lecture, so you know that what happens in kinds of, what is the biggest benefit for DMA controller based data transfer mode. So in DMA controller, the CPU gives off the like entire proceedings of data transfer to a thing called special module, you can say, like called DMA controller. What does DMA controller what does CPU gives is still okay. This is the memory device and this is the IO device between which you need to transfer the data. This amount of data you need to transfer. So what the DMA controller does, it takes all this functionality of the CPU which it used to do for this transfer of data, and it does the same job, and in the meantime CPU don't have to take care of this data, and in the meantime it can do other work, because you know IO is one of the slowest procedures which CPU executes. So for this process, CPU needs to tell him 3 things. One, you need to tell the memory address to the DMA controller. So okay, DMA controller, this is the memory location from where you need to either transfer the data or say like store the data to this memory device. Then it tells the word count. So this amount of words you need to transfer into this memory location. And the third is the address of the disk. So as you have like in previous class, you know that there is not much difference between memory and IO except like the proceedings, but the way CPU treats them, like addressing part, is exactly same. Like each memory block has a address, IO has also an address. So that IO address also he gives it to the CPU, gives it to the DMA controller. So okay, like this is the controller, this is the IO device from which you need to transfer the data. So these are the 3 things that CPU writes to the DMA controller. Once the entire data transfer procedure is completed, it gives it back to the CPU. It tells the CPU DMA controller that okay, my data transfer is complete. The memory which you have requested is now at this location, as you have said. Now you can access that memory. So this is the entire DMA operation in a short form. Like, so if you have any doubt, now it is clear. Yeah. Any other question? I mean that is quite standard MB, GB, KB. So let me just help you. Let me just give you one thing like which may help you. So one is KB, okay, another is KB. You need to know the difference between this. This is kilo bit, this is kilo byte, right? Another beauty is this. Some treats this k as 2 to the power of 10, some treats this k as 1000. Well, like, and if you ask me, both of them are correct. So if you write any question with either 1024 or either 1000, it should be given as marks. Because if you check your like laptop memory, it is always given like 256 GB. But when you check in the procedure, the specification is little less. So this is the reason. Some uses 1024 for conversion, some uses 1000 for conversion. This is one of the difference. And the same rule applies for MB and GB. This is confusing, but people use this term like what to do now. Generally, in the questions, if it is given that take k as 124, 1024, then it's like that. Or if k is given as 1000, then use 1000. Regarding seconds to micro, like sec ms is millisecond is 10 to the power minus 3, microsecond is 10 to the power minus 6, nanosecond is 10 to the power minus that's it. Okay, so we will meet next week again. I guess only 2 more classes are left, 2 more such live session will happen. So next week same time we will again meet. Thank you.